Alright, so welcome back to CAD part 2. So we have a lot of stuff, a lot more to do with CAD. Onshape is a pretty versatile software. So again, I'm Atar, this is
Matthew.
Yeah, so we'll be teaching you. Okay, so if we could open back up Onshape, let's do that. Or or sign into the student account. This is your first time using Onshape. That's good.
Anyone else not signed into Onshape last time? They need like a review. We're good? Alright.
So you can go back to the document you were using yesterday. I think we titled it first. I don't know when you titled it. So yeah, once you open up Onshape, just go. You'll see all your previous documents. You can go to the one you're using yesterday. You'll see your dates will probably say yesterday, or sorry, Monday. You click on it and go in. So is everybody in their document? Yeah, everybody's good? Thumbs up. That seems good. Alright. So today we'll be using assemblies. So up until this point we've been creating individual parts, as you can see in the tabs below. So today we'll be going over assemblies, which are a composition of parts, putting them together. You can see I'm in an assembly right now, and you can see there's still a toolbar, there's still a tree, but everything looks a little different. Alright, so first things first, let's make an assembly. So it's the same as creating a new part studio, except you click create assembly. So everybody create an assembly. It's at the bottom left. Click plus and then click create assembly.
Let's just do names to the templates then.
Okay.
So does everyone have a beam and a T-plate with the corresponding holes in it? Thumbs up if you're good.
Right, I don't think I have that.
That'll check.
So you're in an assembly. Currently it's blank. It's pretty much works exactly the same as a part studio. You have your 3D models and you manipulate them here, and then your toolbars. These are all different tools you can use. And this side tree is same. It acts as a ledger for all the stuff you've done. The functions you've done. So we have to insert parts for us to work with. So I'm gonna go back. So if you look in the current document, so there's different tabs of places to import from. All of you guys should go to current document, and you'll see you have made a beam for Monday. You can click on that beam, and you can place it into your assembly. And then, so what I did was, I went to insert current document, and then I looked for my beam. Alright, we also want to import our T-plate, so you guys would also have that in this document. Or you might have it in some other document. I have it in another document, so I'll go click other documents, and I'll click owned by me, and then, oh, it's right here at the top. So I'll click that, and then, yeah, drag it in. Alright, is everybody good? Everybody? Yeah, up here. Alright. So I've imported the two objects of interest. So now what I want to do is I want to mate them. So to do that, I must use a one of these mates up here. So all these various icons are different types of mates. We got fasten mate, which is smushing two parts together like glue. You can think of it as gluing two parts together. Revolute mate is like wheel and axle. It's like putting two parts together, and then one revolves relative to where you mated the other. So if you have a cylinder, the inside of a tube, you can put you can mate an object to the inside of the tube, and then the object will rotate inside the tube. So probably the most common application is axle and bearing, or wheel and axle. Over here, slider mate. I say these three are like the most used in robotics.
Yeah.
Slider mate also another fundamental like mechanical movement. So whereas this is turning, this is a linear movement. So say if I have slider mates basically work like fasten mates in that they glue two parts together, but you can designate an axis to which the two parts can slide relative to one another. So let's just, I think the best thing to do is start using these mates. So first thing we're gonna use a fasten mate to attach this T-plate to the beam. So I'm gonna click fasten, and you'll see all the functions follow the same concept in that it'll appear here. There'll be a box telling all the parameters of all the areas we want to fasten. So what I want to do is I want to go in here. I want to click on the edge of this circle right there. That's my first mate connector. And then I want to connect it to this hole up here. So I'm going to go and click right over here. And boom. It's like magic. It's fastened. They're glued together. Now, does anybody see anything wrong with this this mate? Yeah. Anybody see anything?
They're inside each other.
Yeah, they're inside each other. So if your mate's inside each other, it's an easy fix. So all you gotta do is you gotta flip the primary axis, and that'll push it to the other side. You'll see though, it's the whole T-plate though is spun in a way I don't want it to. So then I can reorient the secondary axis, which is this button, until it's in the place where I want it to. So then I can click check, and boom, I performed a fasten mate. That's a lot of things to do. So why don't we try and do that? Alright, so good job on fastening the T-plate to the beam. So next thing we're gonna do is we're gonna import more parts. This time we're gonna import from the internet. So everybody can go to Vex, vex.com, Vex Robotics. You can search up Vex Robotics, and you go to the home page. So yeah, Vex is, we get a lot of our robot parts from Vex. They sell a lot of good hardware. We also use AndyMark, other websites, but from Vex you can pull out CAD files for the products they sell. So we're gonna take a bearing, a hex bearing from here. So you can search up bearing in the search bar, and I believe it is, okay, click bearing and then click hardware over here, and then it should, yeah, bearing, this one over here, view details. Alright, so once you get on the page, you can scroll all the way down, and it'll give you all this information. What you want to go to is the tab that says CAD files. So this will give us CAD files for all the different types of bearings. If you click preview, you can see what type of bearing the CAD file is for, and give you a preview of the file. So, yeah. So what we want is, we want the, this one, the 0.5 hex ID, 1.125 OD flange bearing. The third one from flange bearings, up there, go here. And this is the one you want. Alright, you can click download, click download, it'll download up here. Alright, so then you can go back to your document and we can import it. So up here we go to insert again, or actually sorry. First what you want to do is you want to insert new tab and click import. So you go to the bottom left and you want to import. And then you'll want to check your downloads. That's where the files appear. You'll just click on the 0.5 hex file. You'll click open. Alright, Onshape will then give you this prompt. I always go import to this document. Combine to a single part studio also works, but it's like an extra step. So you can just import to this document. Yeah, and you want to import appearances too. Then you'll click import, and yeah, so it's done importing. You can X this out. So now you can see my tabs here are getting pretty messy, but I can go to this file over here. It'll say CAD imports. It'll appear once you if you import something from the internet, and here I can see all my imports. So over here it'll show a part, and that'll be my my bearing. So it's now an Onshape. X bearing, yeah. Alright, so we want to go further?
How's everyone with importing things?
If you're having trouble importing, that's fine. We can continue on with what we're doing. So next, let's work with this bearing. So I'm going to go back to our assembly, and I'm going to click insert, go to current document, and I'm going to insert a bearing. And I'm going to click check after I'm done. Alright, so now that I've inserted this bearing, I want to create a revolute mate. So I'm going to click up here where it says revolute mate. And so what I want essentially is I want the bearing, so see that hole over there, that's a 1 1/8 inch hole. I want the bearing to fit inside that hole and be able to revolve inside of it, have the inner part of the bearing revolve, because that's how the bearing works. The inside of the bearing can move freely. So I click the revolute make button, then I click on where I want to connect to. So over here I'm going to click the top edge here, and then over here I'm going to go, it's pretty tricky, you want to go into the bearing and you want to click this edge right here. This edge right here. There's a couple of edges. It's the second from the outside. So this is the outside, this is right here. I'm gonna click and boom, they're connected. And then once again, I have to flip primary axis. Whoops. Go this way. This way. Alright. I might have to fasten the inside.
Just flip the axis again. It should be and if you just check.
Oh yeah, I just did the other side. Okay, yeah. So I went to the other side. And now I can click check. And now you should be able to, your bearing should be able to, your bearing is connected, that's what happens.
How do you get rid of holes?
So if you ever want to delete a hole, you can just go and click on it in the sketch and click delete. Yeah. So I can just delete these holes. So what we're gonna do. So we've created a bearing, we've imported a bearing, and we've attached it to our model. So next what we're gonna want to do is we're gonna create an axle to go with our bearing, put it to work. So an axle you can create yourself. It's not too difficult. So I'm gonna walk through the steps of how I'm gonna create this axle. I would import the axle, but I can't find the part, and it's quite easy and a good practice to make an axle, as Justin would agree.
Yeah.
Alright, so when you're making parts relative to other parts, you want to first see the part you're working with. So I have the bearing right here, so I want to go to it. And a cool thing about Onshape is you can click two edges of a part, and you can find the distance using measurement tools. So over here, the axle will go inside this hexagon area. So if I click over here and I click over here, Onshape will give me the parallel distance, which is highlighted by that black line between the two edges. So that's 0.501. And if I click this show measurement details, I get a much more detailed overview of all the different measurements. So the parallel distance, this is x. It gives me components of the distance to this displacement and different values. Most of the time though, you can just use parallel distance, because that's what you're looking for. So yeah, use the measurement tool. So yeah, you can use the measurement tool to help you find your measurements for what you want to make. So now that I've found that out that measurement of the hexagon, the diameter, I'm gonna go and I'm gonna create a new part, and then yeah, I'm creating a new part. I'm gonna make my sketch, all that, and now I'm gonna make the axle using the sketch. So we've used line, we've used corner, rectangle, all this circle. Maybe you've experimented with arcs. I'm gonna use a inscribed polygon and click over here, and I click and drag. Boom, and I click again, and so it'll once I click, it'll go into this prompt of how many sides you want to make. You don't have to have it exact. You can just click, and then you can edit after you've declared the polygon. So I want it to have 6 sides, and I know from my measurements earlier that I want it to be the radius to be 0.5. So this inner construction circle, I click on that and I click diameter of 0.5. Some of you guys may have noticed that the outside on the bearing, the diameter showed like 0.501.
Yeah.
That's accounting for sorry, the word's not coming. The corners and like
there's a slight bevel.
Yeah, slight bevel. But yeah, it's 0.5. So I made my hexagon. You might notice that even though like I have the hexagon I want, it's still undefined. That's because it's not defined in space. So even though it's like on the origin, it can't move. I can still drag these points and like curve it. So if that bothers you, what you can do is you can drag it to the horizontal, or you can drag it to the horizontal, or you can mate it. So this, I click this point, I click this point, then I can go down to this tree, click horizontal, and that'll lock it in place. Doesn't matter too much, but it's good practice. Alright, so next I want to extrude. So click extrude. I want this like 12 inches, that's good. And then click check. So yeah, now we made our axle. Alright, so after making our axle, I can go back into my assembly, excuse me, and I can insert it. So once again, you go, it's in my current document, I scroll down, not scrolling down, sketches. Parts do you have 5? Yeah, but if it didn't show up, what go here. Drag it. Click it? Yeah. Okay, wait. Why can't I move this down? Technical difficulties. Seems like I'm locked in place. Wait, let me X that. Insert. Wait, why can't I go see? Alright. I think it's Part Studio. Yeah, Part Studio 7. Okay, I just had to search it up. Alright, so this is a good example of organization. You don't want a bunch of Part Studios or like parts named Part Studio 1, 3, 4, 7. When you're making something, you want to name it. So I could have named this like Part Studio 1. I could have named it like Spacer. Part Studio 3. I could have named it Beam. This one I could have also named Spacer. And I could have named this Axle. So yeah, you should do that. I might go back and I would go back and do it.
You should show them how to rename it.
Yeah, okay, I'll show you how to rename it. So say I go into this Part Studio, oh, it's my spacer. So you can click over here and click rename. So if I right click, I can click rename and I can type in spacer. And that's how you rename your parts. Otherwise, sometimes you'll have a lot of different parts and it'll get really unorganized and you'll spend a lot of time searching for what you want. Same with this assembly. I can rename this to first assembly. I didn't spell that right, but sorry. Alright, so we have our axle and we have our bearing and they're both in the assembly. Now we want to mate them. So we're going to use a fasten mate again. And what we want to do is we want to fasten one of the inner sides of the bearing to one of the sides of the axle. So I click fasten mate. It'll prompt me for 2 connectors. I click here. That's one selected, and then I can click here. That's the other. And once again, it'll take some time for. Okay, it's in there. I'll have to rotate until I get the desired orientation, and I click check. And X this one out. That's not what I want. And now, okay, wait, let me fix this. Now if I click on this edge, you can see the revolute mate. So everybody look up here. So I put the axle in the bearing, and because the bearing has a revolute mate, I can click on an edge and it'll spin the axle. That's pretty cool. Yeah? And that's because this in here on one of the circles is spinning. And it's attached though. Yeah. Your revolute mate is not working, and that's because what Onshape is doing is alright, so you're trying to spin the axle, but the beam itself is also trying to spin. It's not locked in place, so it's not gonna work. It's like you're spinning the whole thing. So what you want to do is I clicked on the part, so I clicked. So over here you have your part tree. So each of these can select the whole part. So I clicked on part 1, which is my beam. I right clicked and I clicked fix. And then what that does, that'll lock it in place so that it won't spin. So your revolute mate will work. So I went up here.
On the part tree.
Yeah, right click on the part tree and click fix. Matthew, go over is that a lot of you guys said that like your axles were like they're all sticking out of one end. Like see how mine's in the center, your guys was in like sticking out one end. That's because I had told you to use a fasten mate. And that'll just as Matthew explained, the objects, the parts, even though they have volume, they don't necessarily have collision. So they only collide if you specify relations in mates. So if it's a fasten mate, it'll just glue it in that place. So you have to use a slider mate if you want to adjust the placement of the axle inside the bearing. So if I unmate this, I can drag it out. Alright, then I click over here and it says slider. So I use the same connections. I click there and I click the inside here. And I click this primary axis. I solve. And I should be able to slide it in and out.
Yeah.
So what happened here is that the slider axis, so the slider mate works so that it only slides on one of the axes. I think right now, I think it defaults to like the z-axis, right?
No, it'll default to the perpendicular of the two faces you mate.
Yeah.
Yeah, it's kind of an odd feature.
So to change that, you have to go into the slider function, edit, and then I think it's in simulation connection, or no, it's.
I don't actually know how to do it.
Yeah, wait. I learned this last year and then I forgot. No, it's in here. Okay, Z maximum is not. Oh, rotate about X. Okay. I think it's rotate. Would it be Z?
I don't know.
Let's
I
change
don't
it.
use slider mate.
I wouldn't use slider. We usually use which one do you use?
So use the one that you usually use. Why are you taking on the slider?
The
None of you
sliders-
guys use
Slider we do use, but
We do use, but
we
like,
do use, but they're kind of tricky.
if we have an elevator, you know. Or like
I used it all last year, but I honestly isn't really good. Wait, what about Y? I think Y would work.
That's
Alright.
only for the offsetting, though, I think.
Yeah.
Yeah.
There used to be like a different prompt that you can change like where. Like there used to, I feel like I swear this used to be different. All right, we'll get into. Me and Matthew will figure that out. But we'll go back.
For now, you can
Oh
what is this slider? There's a slider there. What you can do for now is just use a fasten here. There's this face of the bearing, and then up here, when you have this face, you can do it for the middle of the axis instead of the exact side. So if you want a symmetrical, it's there. But it just can't move from there.
We'll get back to you on the slider, mate. That is a pretty important function. Kind of tricky for us too. Shows.
So now we'll do the square.
Yeah, we'll go into the drivetrain. All right. So Matthew over here has a demo drivetrain he made. And that we're gonna. All right. So at this point, we've kind of learned everything, right? Mostly everything.
Basics, yeah.
Basics, yeah. So now is a big step. You're making a drivetrain. So that's the base of the robot. It's the chassis. It's like the undercarriage. It has the wheels, the motors. Do you want to put motors on this? Okay. But yeah. So over here is the general outline of what we're gonna have you make. So you can see. We made it together, these beams with the T-plates, and it has these various bearing holes. So you guys are going to assemble this in your own documents. One thing I want to add is that for all, I want you guys to at least put in all the bearings for each side of each of these holes. And for at least one of them, you can do it for all of them, but I want you guys to put an axle that goes across one of the two holes, and it follows the revolute mate. It can spin, so you guys should make one spinning axle. You don't need to do all three because that's tedious, but I mean, if you can, you should, because that's it'll show a complete project. But yeah, so that's the next step. Anything you want to add?
I'll just draw some dimension.
Yeah, there's some dimensions on the board. You can draw it. It's 24 or 26.
So
so look up here for a sec. You guys can work on your project. You have plenty of time. So all right, let me unfreeze this.
You add one to
But this is the full span basics.
So I told you guys to make this slider mate. So oh what? Okay. So I got this slider mate working between these two beams. Sorry, I'm kind of doing a weird view. Okay. So these two beams, I got the slider mate working. So the main difference. So what I did differently is that when I told you guys to make the slider mate the first time, I told you guys to make the two faces. You actually want to make the two edges. So what I mean by that is if I go to this mate over here, I can delete this facet mate. Delete that. Okay. So that's no longer mated. So when you make the slider mate, you want to click the edge over here. So instead of clicking the face, you want to click the edge, and then you want to click the edge over here. And then, click the primary axis. I click the two edges.
Would you click one edge of one thing and one edge of the other thing?
Yeah, one edge of one thing and one edge of the other. Oh, you have to rotate it. It's a little harder to get it.
Wait. Are you going to need to know how to use the slider for robotics?
Yeah, it's pretty useful. I used it a lot last year.
Wait, do you have to rotate it?
I don't know. I don't know what it is right now.
Oh, I see.
Okay, wait. Axis.
Oh, I got it.
Let me go here. Click here.
I think to fix it.
Oh, yeah.
Oh,
I did not get it. Is that correct?
To get it to work, okay, so to get the slider mate to work, if you look up here at the icon, you'll see that the slider mate, between the you'll see these two black lines. That means that you want to work with edges. I remember now. If you work with faces, the way it defaults to is that if you click a face in a face, it'll, like Matthew said, it'll move perpendicular, so they'll come apart and go through each other, sort of like this. So you wanna click the edge here, and you wanna click the inner edge of the bearing. And if that doesn't work, I'd suggest fastening it as well as doing the slider mate. I would fasten I try to also fasten it. I think that is the fix. Alright guys, I don't want to take too much of your time.